Okay guys, so I'm going to work out just some extra gas Stoich problems that are different than the ones that are on your PL. This is just to give you extra practice. This is definitely not a requirement or um, anything that you have to do. It's just for your own benefit, right? So what I have set up here is some gas stoichiometry practice questions, and then I'm just going to work them out here on this side. So our very first question, we have a balanced equation, and it says that we have two hydrogen peroxides that are degrading decomposition reaction into water and oxygen gas. And it says how many liters of hydrogen peroxide are needed to make 6.5 liters of oxygen gas at STP. And so big smile there. At STP means we just get to use stoichiometry in T-charts. 6.5 liters of oxygen goes in my first box. I need to cancel out those liters and convert that to moles of oxygen. Once I'm in moles, I can use my mole ratio. Every mole of oxygen comes from 2 moles of hydrogen peroxide. And then every mole of hydrogen peroxide is also 22.4 liters. What's nice about gas stoich at STP when it comes to volume conversions is that you are dividing and multiplying. And so really all you have to do is 6.5 times 2. And so that's going to equal 13 liters of hydrogen peroxide as question number 1. In question number 2, it says how many grams of water are needed to make 4 liters of hydrogen gas at STP. So again, we have a balanced equation. Sodium plus 2 moles of water makes 2 moles of sodium hydroxide and 1 mole of hydrogen gas. We have 4 liters of hydrogen gas, again at STP, smiley face. You can't see my smiley face. There we go. Okay. And then we want to find grams of water. So grams of water, again, this is going to be a nice, simple T-chart. Let's not lose our sig figs there. 4 liters of hydrogen gas will get converted to moles of hydrogen gas. At STP, we can just divide by 22.4. They're in a 1 to 2 mole ratio of hydrogen gas to water, making sure we keep our substances straight so we know where that goes. And then every mole of water weighs 18 grams. 18 grams per mole. So then 4 divided by 22.4 times 2 times 18, that's going to make 6.4 grams of water in question number 2. Now from here on, they are going to get way more complicated, right? Because now we're not going to be at STP conditions, we're going to be at non-STP conditions. So starting at number 3, our balanced equation is that 2 moles of sodium chloride react with 1 mole of fluorine gas to produce 2 moles of sodium fluoride and 1 mole of chlorine gas. How many grams of sodium fluoride are produced from 150 liters of fluorine gas? But now we're not at STP. We have a pressure of 0.893 atmospheres and a temperature of 25.2 degrees Celsius. For every degree C, go ahead and add 273. And now that I have a volume, a pressure, and a temperature, I know that I'm going to use PV equals nRT. My pressure is 0.893. My volume is 150 liters. I don't know my moles. My constant is a constant, and my T is T. So then I'm just going to divide these two over. in my calculator. And I get 5.47 moles of what? So all of this stayed from liters of fluorine. If this is liters of fluorine, then these are moles of fluorine, which means these are moles of fluorine. Knowing that I don't need to go back into grams, but to change substances, I have to use my mole ratio. So every mole of fluorine produces 2 moles of sodium fluoride. And then every mole of NaF, 23 plus 19, is 42 grams per mole. And so 5.47 times 2 times 42, that's going to give me 459 grams of sodium fluoride for number 3. Okay. Number 4 is even more complicated in that even the pressure is not in R units. It is in torr. Okay, so for number 4, again, we have a balanced equation. We've got ethene, so 2 moles of C2H6, that's ethane, sorry, and 7 moles of O2 yields 4 moles of CO2 and 6 moles of water. Okay, and so this is a worksheet that I've done in the past, and what we're going to have to do is we have 2 sets of volumes. That's a limiting reactant problem, and so what we're going to do is just change these words. Just to make them read a little bit differently, because you guys are not ready for limiting reactants today. So if I have 13.9 liters of ethane and excess of oxygen, which is a nice thing, but this is at 26 degrees. 26 plus 273 is 299 Kelvin. And a pressure of 755 torr. I don't want torr. And every atmosphere contains 760 torr. So 755 divided by 760 gives me 0.993 atmospheres. And it asks how many liters of carbon dioxide are made. Okay, so this is a more complicated one to go from volume to volume at non-STP conditions because you have to use PV equals nRT twice. So I'm going to call them step A, step B, and step C. So A is PV equals nRT to take that volume and find the moles of ethane. Then in B, we got to set up a mole ratio of moles of ethane and finding moles of carbon dioxide using my mole ratio. And then in C, we got to go back to PV equals nRT to get back to volume. Okay, so this is going to be a longer question. So to start off, we're going to use P V equals N R T. Here, my moles is 0.562. And again, this is a volume of C2H6. So that's also the moles I'm solving for, C2H6. So 0.562. They are in a 2 to 4 mole ratio according to my balanced equation. So to switch substances, I always have to do a mole ratio. So I'm going to times 4 divided by 2, or you could just multiply by 2. I mean, it's really up to you. So 1.12 moles of carbon dioxide are how many moles I produce. Now I'm going to plug that back into PV equals nRT. My pressure is still 0.993, but this time I want the volume of carbon dioxide, knowing that my moles are greater due to my mole ratio. And so volume is going to equal I feel like I typed that in wrong. I'm going to try that one more time. I think I typed in 0.933. 1.12 times 0.0821 times 299 divided by 0.993. There we go. So 27.7 would then be my liters of carbon dioxide for number 4. Okay. The same mistake has happened again in number 5 with limiting reactants. And so let me erase this, and we're going to change some words over here on the side. It says how many liters of ammonia are made from excess hydrogen gas and 20.78 grams of nitrogen gas at 8.94 kilopascals and 32.5 degrees Celsius. And so we're going to work on our balanced equation is N2 plus 3 moles of H2 yield 2 moles of ammonia, NH3. I know that I have 20.78 grams. Knowing that I'm starting with grams and I'm trying to find liters of ammonia at a pressure of 89.4 kilopascals and a temperature of 32.5 degrees C. Which is 305.5 Kelvin. I know that this isn't going to go directly into PV equals nRT. I need moles of the ammonia to do PV equals nRT. So here my first step is to take my grams of nitrogen and to find moles of ammonia. So nitrogen weighs 28 grams per mole. And for every mole of nitrogen, I form 2 moles of NH3. So then 20.78 divided by 28 times 2, that's 1.48 moles of NH3. You wouldn't want to find just moles of nitrogen gas to find volume, because that would only give you volume of nitrogen gas. So make sure that if you're looking for ammonia volume, you need moles of ammonia to do that. The substance should be the same for every PV equals nRT. So in this situation, my pressure is 89.4. I'm going to keep it in kilopascals. I'm just going to change my R value. There are 2 R's on your yellow sheet, 1.48 moles, and I can just change my R to be 8.31. This is the one on the back of the periodic table, not the AP, the pre-AP yellow sheet. 305.5. So I'm going to divide by 89.4 on both sides, and that will give me a volume 1.48 times 8.31 times 305.5 divided by 89.4. So that'll form 42.145. Sorry. Depending on, I did not round this number, I kept it the whole way in my calculator. So as long as you're close and you always show your work, that's how we get credit. And that is going to be liters of ammonia. You need a number, you need a unit, and you need a substance. Okay? So I hope that helps. Have a good day.